model the sequence of figures using a table, graph, and recursive and explicit equations to show how many dots are in the pattern at t minutes. Alright, so I've made a table, and the column on the left is t, which is the time interval. So what we have at the beginning, we have 3 dots. At 1 minute we have 6 dots. 2 minutes we have 12 dots. 3 minutes we have 24 dots. And 4 minutes we have 48 dots. And maybe you guys have seen that after each minute the number of dots doubled, just multiplying by 2. So the recursive equation, you need 2 parts to it. First is the starting point, and that's what this is. F of 0 equals 3. That's the very first thing we're getting. And then the next part describes, to get to the next term, you take the previous term and you multiply it by 2. As far as the explicit equation is concerned, we have to look at the pattern. We have 3 times 2, 3 times 2 times 2, 3 times 2 times 2 times 2, 3 times 2 times 2 times 2 times 2. And I suggest we rewrite this part using exponents. 3 times 2 to the first, 3 times 2 to the second, 3 times 2 to the third. Whenever we have repeated multiplication, we can rewrite it using an exponent. And the top one is 3 times 2 to the 0, because anything to the 0 power is just 1. So that's 3 times 1. And now we look for the pattern. Everything stays the same except one thing that constantly changes, and that corresponds with the t column. So if we rewrite our equation as 3 times 2 to the t power, anything that ends up in the t column will give us our number of dots that we want. So our explicit equation looks like f of t equals 3 times 2 to the t power. The last thing it wants us to do is to make a graph. So that's what's happening on the left side. We're just gonna graph all those coordinate pairs, 3, 6, 12, 24, and I can't really fit 48 in here, but you get the picture. And this graph is curved. This is a geometric sequence. Thanks for watching, and don't forget to subscribe.